Hello everyone and welcome back to the channel. So today we'll be talking about the battery swapping technology for the LCV vehicles, light commercial vehicles. So LCV vehicles are basically very popular, especially in the commercial market. And talking about the battery swapping technology, it's not a new thing. Battery swapping technology was started in 2009 by a Better Place company, and they were the first company to do it for an car segment vehicles. Battery swapping for Better Place basically tries to collaborate with Renault, but by the time they basically come up with the new product and the battery swapping technology for the cars, they were basically asked to file a bankruptcy, and it's a huge different case. But in 2015, 16 and 17, we saw all over the globe in a different timelines going for a battery swapping, especially for the two wheelers. If we'll talk about the delivery partners, if we'll talk about the commercial segment, especially in the two wheelers, battery swapping is one of the most leading things, and every commercial you can say owner, or if you talk about the every fleet owner, wants to basically get into the battery swapping because it lower down the cost of the vehicle, as well as it basically does not give them any burden of the battery to maintain the battery life and to look after the batteries. So battery swapping is a totally different game, and it's one of the most important thing I see in the coming future for the electric vehicles. That's why in the future you will see that it will be coming not only for the bikes but for the buses as well as for the light commercial vehicles. So in this video I'll be basically discussing about the technology and how we can evolve and how we can bring this to an LCV vehicle with this technology. And basically it's a way through, or it's basically you can say a research paper. You'll get to know about the battery swapping for the LCV. So in this video we'll be basically discussing about the Volkswagen vehicle, and this vehicle is basically around in 3.5 ton of a gross weight. So talking about the first glimpse of how it's going to look into this whole system is like, if you'll see this image, no, this is what it's going to fit inside the vehicle, underneath the vehicle, and it will basically hold all the batteries as well as the BMS system which is required for the battery. And this system is basically is not going to use for the battery swapping only, but it can be charged with an external charger also. So depending upon the situation, depending upon the location you are in, you can use both this system as you want, if you want to swap the batteries for the fast charging and get the swapping technology usable in your vehicle, and you can charge it as well using the external chargers. So talking about this, so battery swapping brings so many advantages as I was talking about. So in this you can basically purchase, lease and rent and exchange the batteries. That's why battery swapping is basically more popular in this segment, especially in the fleet market. So talking about the requirement and what particularly we can take in, we have taken account into this project is the quick and reliable charging of the batteries, automated connection of the battery to the vehicle traction and communication network. That's very important because battery needs to be tracked every moment and everything about the vehicle as well as about the battery, because it can be changed and it can be so that it can be easily swapped with the system. So easy to access the battery, which is one of the most important requirement for a battery swapping. It shouldn't take more than 2 minutes to swap your battery if you're talking about the LCV vehicles. Safe connection to the vehicle structure, it shouldn't it's also one of the most important. These are the criteria which were taken into consideration before developing this whole product. And one is the minimal number of interface for the reliable charging process. Okay, abandonment of the liquid cooling. If you put it the liquid cooling, it would be an issue, because sometimes what happens is during the swap, if any part get damaged, it can cause a problem to the system. And there are basically 3 variants in this: 13, 26 and 39. So this 13 is the basic number of pack, and using it into multiple times we can basically get 26 and 39, and a different range that we'll talk later in this video. So stick to this video till the end. We'll talk about all these kind of things in a detail. And it has a standalone BMS system which will be monitoring and communicating with the vehicle and the external charger. External charger stands with your DC chargers and your swapping. So with the 2 things, it needs to be basically take into consideration which one is working and which needs to be taken into consideration. If it's going for the swap, it should have electromechanical system like this. If you'll see, this is a connector. It should release on time. It should communicate with the system, and it should get all the things so that it can be demounted from the body chassis. So talking about this whole figure, if you look at this is the battery packs, and these system, this is an extra battery pack, or you can say this is storage for the BMS as well in some system. But going forward, we can see there is an extension of one more battery. So this is 13, 26, 39. If you'll use only 13, you'll get around 50. If you'll use 26, you'll get around 75, 85. And if you'll use 39 kilowatt of battery, you'll get around 100 and 118 kilometers of the range per drive. So talking about this figure, if we'll talk about the battery mounting, and this is the battery, this is the mounting. Okay, and these packs are basically you can say that these packs are in such a way that it can be it's called as PHEV2 packs. So talking about this term, this is basically a standard form, and it was bring up by the Germans automotive industry to commonize the swapping technology in the Germany. And these are all prismatic lithium-ion cells and have a capacity of 37 Ah each. Okay, so talking about the structure, if we'll talk about, these are in 96S and 1P. There are 24 number of cells in each pack, and these each pack, and if we talk about the each pack, you'll get to know that these are very different and have a separate BMS for each one. And if you talk about the PHEV2, they have a specific height, width and thickness. So talking about the length, it's around 148 mm. Talking about the height, it's around 91 mm. And talking about the thickness, it's around 26.5. So in this format only, this PHEV2 cells or you can say packs are to be formed, and these are standards so that it can be used all over the German or all over the automotive industries. And they are basically asking all the automotive makers to follow this and to generate a battery swapping as a commonized platform, so that we can take up the fast charging and we can basically resolve all the issues that are coming up regarding the charging into the automotive industries. And if you go in detail about this, how this is going to look like, this is what basically a single pack is going to look like. Okay, so on the top it has a BMS balancing. This is a 13 kilowatt battery pack. This is the conditioning. Talking about the conditioning and talking about the cells, we'll got to know in detail how this cooling system is working if we are not using the water technology or the liquid cooling. So this is basically a HV separator. This HV separator is basically connected to an electrical connection, which is basically using as a Chagori connector, which I showed you in the first image. This first image, if you look at this is the connector. So talking about the connector, it's basically communicate with the high voltage interface connection with the vehicle and with the external charger. This is the vehicle, it's mounting underneath the vehicle. So talking about each and every cells, depending upon your configuration, if you use the 2-digit, then it will move ahead and it will take the signal from this as well. And if you are using another 36, then it will move ahead and it will take the communication from this. So these are your fins. Instead of using of cool liquid, we are using an air cooled technology. Why air cooled? Because it's quite easy. And if you talk about the automotive configuration and building the vehicle, you will see the most of the air that goes around the aerodynamic. It's basically, if you look at the vehicle, suppose your vehicle is moving in this direction, all the air that goes around, it goes around like this, and it goes down drag. So these are called your drags as well. These are your down drags, and which basically helps in cool the system over here. And so the plenty amount of air is present to cool this battery. That's why we are using an air cool system, and that's why it's very important to have a fins underneath. So this fins is going to look like this. If you look at this image, this is your fins, which is basically help in cooling down the whole system, and this is the whole connection underneath the vehicle. And these are your BMS, this is the cross section area, these are your Chagori connectors and all. So this is what basically a whole system is going to look alike, and these cells are basically packed into a copper foils. How this copper foils is helping is basically this copper foils are fixed into 2 modules. So for this we need to get into more detail, and we need to understand this with this image. So this red one is basically your copper foils. Underneath it there is a mica sheet which basically gives them the strength and robustness so that it does not break, it does not get loose, and these sheets does not allow the cells to expand as well. Sorry, to expand. So what happen is during the whenever we are charging and discharging the cells, they get basically expand, and we shouldn't let our cells to expand to a certain limit. To a certain limit it's allowable, but going beyond that it can basically damage the cells and the battery pack. So we shouldn't allow it to basically get it expand. So this mica sheet and the copper foils are not allowing any kind of this kind of things to be happening around this battery cells, and it protect the whole system in such a way that the battery packs are intact in this whole system and does not expand or does not get impacted due to any kind of mechanical impact or the vibration or something like that, whatever is happening when we are driving this on the road. These 24 cells are in such a way that it can basically be demounted, and if you want to basically exchange it, it can be easily exchanged because they are closely intact in a same pouch, and they are basically connected with a mechanical connector. If you look at these small images, these are the hinges. These hinges are basically not allowing anything, and it can basically allow to easy demounting and mounting of this whole battery packs into this system. So this is what basically a whole mechanical system is looking like. Now we'll move into the another segment. We'll be talking about the analysis of it and how we are basically coming up with the how it's basically performing under the simulation part, and we will talk about how it's performing under the real world condition. So talking about the simulation part of this whole project, if you talk about this, taken is under World Harmonized Light Vehicle Test Procedure. So WLTP is the name of this whole process. And if you talk about the battery masses and the range, so in this, if you'll talk about, there are different ranges what we are getting from this whole system. And if you talk about the number of stack and giving up these basic details, so this is a single stack. The single stack is around the 15 kilowatt hour. It weighs around 261 kgs and it gives us a range of 53.5. So this is a battery mass and this is the range. As basically we are increasing the masses and we are basically increasing the kilowatt hour, we are basically increasing the range. That's why it's very important to understand everything in an automotive industry with the help of a simulation. Whatever we are doing it, whatever we want to do it, it's basically working very fine. It's working as good as the you can say basic or you can say a neutral conditions, and it shouldn't be at par. If you're talking about the simulation of anything into a mechanical or an electrical world, it basically gives us the rough idea how the system is going to perform. So this is the battery mass. In this we have basically taken a speed of 90 kmph of the vehicle, and in this the battery pack, it's basically working under plus minus 2C criteria. And in this, if you'll talk about the current, it's basically around 250 Ah. So in this three conditions, we have basically simulation all the different criteria. First one is the range thing. If it is increase the number of stacks, we are basically increasing the number of range, and we are basically increasing the masses as well. So in the future challenges, what we need to do is we basically need to come up with the lighter cells so that we can basically reduce the mass of this whole system. So suppose it's with a 3 stack, it's around 500 kgs, which come up with the which will be talking about the number of system and the gross weight of the vehicle as well. So it's going to increase up to the 1000 or 1500 ton. So in this kind of things, we need to basically come up in the future, which is basically a huge challenge, and basically working on this kind of thing so that we can basically reduce the number of weight of the battery packs as well. So talking about the thermal battery temperature, it shouldn't go beyond 35 degrees, or you can say beyond 60 degrees Celsius under the operating or discharging condition. If it's going over and above the 60 degree, then it's a huge concern for the whole battery packs, because as we increase the temperature, it basically deteriorate the chemical inside the cells. It started to decompose, and this decomposing leads to short life of your battery cells. And the short lives in duration may cause thermal issues, and even with that it can cause burn, and it can basically reduce the overall range what we are expecting into the system. So this is what a whole thermal simulation of the system is looking like. These are the fins, these are the battery packs, how it's going to perform under the different conditions. These are the things. So if you look at the scenario under a heavy load condition and under extra heat generated, it's basically the heat is basically generated between the cells, which is basically dissipating with the help of the whole system and the cool fins. That's why it's very important to understand whatever the system or thermal system we have made, it's working very fine, because the heat which is generating between the cells, it should dissipate all around this all around the body, and it should pass to the fins and to the environment with the help of the air cool or the liquid cool, whatever we are using for the system. We are using air cool and it's working very fine. You can see the most of the system is in the green conditions, and this whole red region which is present in between, it's basically dissipating the heat all around the system in a very smooth manner. So this is what basically simulations look like, and during the simulation found out that it's working very fine, and we can go ahead and basically build the system around this whole system. So this is what a standalone BMS looks like for the whole scenario. This is one of the most interesting thing. It's built on the automotive standards. It's going to work as a brain of the system, and in this we are using a master and a slave concept. So in this, what we are having, if you look at the whole scenario, if you look at the previous images, so you'll find out that these are your slave system. These are your slave, okay, because it will need to change, and it will need to get updated as well. And inside the vehicle there is a master communicator which will be communicating with these battery packs and allowing it to use it to the full utilization, and it will be allowing it to monitor it properly. So what happen is, in this whole scenario, what happening is the master is inside the vehicle and the slave is outside in battery BP packs. If you'll talk about battery packs, so what happens is, whenever we are changing this battery packs, it's not like it's going to communicate again and again. It will basically register into the master that we have changed it, and now we need to work on the with the slave which has changed. And if we put on the external charger as well, it shouldn't be like every time we are putting the external charger, it's communicating with the outside battery which will be changed, which will be basically moving out of this vehicle. It should be communicating with the whole with the one master solution, and it will basically allow it to communicate with the slave and allowing it to charge, and it will allow it to swap as well. And this master and slave concept basically allow us to generate multiple parts, multiple things, because slave can be replicated multiple times, but the slave of the master of the vehicle will communicate inside the vehicle with the battery pack, with the external charger. So it should be the individual one, and it should be the central part of your system. Master's slave could be changed and could be replicated multiple times with the different components. That's why master and slave concept is quite good, and automotive industries, especially in the swapping technology, they are using it very frequently with the system. Now we will talk about how this system is going to be mounted. This is one of the most interesting and electromechanical component if we'll talk about for the swapping technology. I think for the LCV concept, it's very interesting to have a better you can say decoupling and coupling system, because it's quite sturdy. It needs to be quite sturdy, and it should be safe as well, because the LCV vehicles will be moving not only on the smooth road, but will be going around the urban areas where this road are not that good, rural areas where the roads are not that good. So we need to basically see both the road conditions, and we need to build this system in such a way that it should be able to cater both the environments, rural as well as the urban areas of the road conditions. So going into depth of this whole diagram, if you look at these are your mechanical parts, and these are basically holds the suspension as well as the shock absorber for the system. So whenever we are doing any kind of swapping, so what happens is, this is basically where the whole system gets railed, and this is basically where the battery packs are mounted. So these are your mechanical part. These will be fixed inside the vehicle, and these are made in such a way that it's a plug and play system, and it's a blind plug and play system. It's not like you'll have to adjust anything. It will just go into inside the same segment of the you can say holes or a platform, and it will basically get the whole battery packs mounted inside with the Chegori connector, and it connects very easily. It has a damper as well in this whole system. So what the damper do is it's basically absorb all the extra forces that are working on the vehicle, and it does not allow it to transfer it to the battery packs, because if it get transferred to the battery pack, what will happen is with the vibration and all these kind of things, NVH, it will basically get damaged, and the battery packs might lose and cause short circuit inside the vehicle. So these kind of things need to be looked after while designing this, and this whole electromechanical is one of the most interesting thing. So this has a damper, this has a connector. These are made for the blind plug and play system. Plug and play is kind of different. It's basically you are seeing anything and you are joining it. It's basically like your charger, plug and play. But blind is like if you are not even concerned about the holes, it will just go and sit in that exact hole multiple times. And these are made and tested for 10,000 life cycle. It's a warranty, you can say, from the manufacturer that for the 10,000 times, these whole system, this mechanical connector, electromechanical connector are not going anywhere, and it will protect your system like a new one. So this whole 10,000 life cycle of this system, having a damper, electromechanical, blind connection, these things are going to make this more robust and more easy for the swapping technology. Because one of the biggest concern about this swapping is it should go and fit inside the vehicle in a proper way, and if there is any loose you can say connections, it can cause damage to the vehicle, to the battery. And lithium ions or any kind of cells which has a lithium in it, it's kind of an explosion if it's getting a spark. So these kind of things need to be taken care. And so at the end, I just wanted to give you the whole brief what we have saw in an animation. It's basically, this is how a whole system is going to look alike. This is your connector, this is your battery pack. This is how they are basically connected to each other, and they are communicating master and slave. So this, one of the most interesting thing about this whole technology is that it's still considered as a lightweight, being a three stack system of 500 kgs. It gives you a range around 100 plus, and swapping in 2 minutes. These are few things that is going to make this technology more power. And I think in India we need to bring this kind of technologies. My major purpose of giving this idea and to give this research on YouTube is that so that anyone could see and we can work around this and we can build this product for Indian market. Because LCV vehicles, if you talk about Maruti Magic, Tata Ace, these kind of vehicles are more popular in the smaller segment of commercial market, and fleet owners own these vehicles, and we can basically build it as a retrofitment, and we can give them a solution for their vehicle, so that an extra life. If you talk about the diesel and petrol vehicles, they are mostly going to extend in few years, and most of the market has a diesel vehicle with this whole LCV segment. But now we are quickly switching it to electric, but electric also takes 2 to 3 hour times, which is basically they're going to harm their pocket and going to basically stand their business. And to let the business go running, we need to have a battery swapping technology for the LCV market. I hope you enjoyed this video, and if you have any kind of questions, if you want to have a discussion on any kind of things in this video related to this video, you can feel free to comment down below. Like this video, share this video with your friends and family so that they can understand about the battery swapping for the international for the LCV market. And for this video till here only, and I hope you enjoyed this video. Thank you for watching this video.